Can material science and product design fix a crisis they created? Well, to find out, we'll be speaking to the founder and CEO of RhinoShield, a Taiwan-based company investing heavily in research and development to rethink how plastics are designed, used, and reused. I'm Divya Gopalan, and you're watching Connected on Taiwan Plus. Thank you so much for being here, Eric.
Thank you very much for having me.
I understand that you studied material science and engineering at Cambridge University.
Yep.
And it was during that time you accidentally discovered a shock-proof component. So can you tell us a bit more about that?
So my PhD was about using hydrogen fuel cells to generate electricity. So during my experiment, I had to use hydrogen in high temperature. You know, hydrogen can potentially explode. At the same time, I have to watch my experiment. So I had to create a material that is transparent. I can put on top of safety glasses. So when explosion happens, it will keep me safe. There's nothing like this off the shelf. It was my side project to create like a polymer blend that is transparent, at the same time can absorb impact.
Hence the shockproof.
Yeah, and then later on I discovered actually it does really good job in terms of protecting glasses. iPhone just released, and then it was the first time cover glass was used instead of plastic. And then I thought, hey, maybe I could run a Kickstarter campaign. It kind of just started from there. Like we got a lot of pre-order, we got a lot of interest. So it took us a year to fulfill all the orders because I kind of underestimate the difficulty of mass production. So initially it's like a student project, right? And then later on, I realized, hey, you know, I have to mass produce this. I have to fulfill this. Customer were happy. They say, hey, can you make a compatible phone case? That's how we kind of really turn this into a business. And now we have like more than 600 people working with us.
For myself and for our audience, explain the concept of material science and why that's been so important.
It is a discipline of physics, chemistry, and math all together. Everything you see, everything you touch is material. You're kind of like an architect, but on the molecular level. Let's use semiconductor as an example. When you want to make things smaller, material science becomes so important because it's the roadblock of where technology advances. So every kind of staircase advance, a lot of building block is always materials.
And one of the things that you have truly been looking into is the idea of recycling plastic.
Plastic, we know, is really a big issue, and no one is really looking into this. We produce a lot of plastic, but 90% of it, we just either landfill it, incinerate, or throw this in the ocean. Only 9% of the total plastic is being recycled and then reused as plastic products. I want to focus a bit on policy. There's no restriction, there's no regulation on product design. You can design a phone case with multiple material glued together. That just makes recycling impossible. You have to do sorting, you have to pick individual pieces out. That just makes recycling so difficult. Either you incinerate them, or you landfill them, or you export them to place like Philippines, Malaysia, and then they throw it on the ocean for you.
Yeah, exactly.
But that kind of reignite my career. When we design our phone case, we design backwards. We first design how this is going to be recycled. Sometimes you can't have monomaterial design. Like my phone case, you have magnet and you have plastic. In this case, we have to be able to design for disassembly. But a lot of other companies just glue everything, bolt everything, make disassembly irreversible. It's an economic problem. We know technically we can infinitely just make phone case without consuming new materials. And that phone case will turn into phone case forever. I think circular is so important because that will buy times for the future plastic.
Right. Okay, and that brings me to circular blue. And you mentioned cleaning up the oceans and all that legacy plastic there. And that's another one of your big projects. Can you tell us a bit more about that?
Yes, so I was thinking like, is there any way we can go plastic negative? So that's the point where I started to source for ocean plastic. During my research, I realized there's not many people
providing the ocean, which is how I was going to ask you, where are you getting your ocean plastic
exactly.
from?
And then a lot of this organization is depending on grants or donation, and the supply is never constant. They are not doing everything in scale. It's because they are not linking this activity with business. When you combine ocean cleanup with a business, then you can really scale the whole operation. That's why we start kicking off this project, and then with years of research and then brainstorming, we come up with this idea to create a mothership and then drone. It's almost like a robotic vacuum for the ocean. The drone will actively go collect ocean plastic. The mothership will act as a collector. And then because everything in the ocean is so huge, we could potentially use the space on top of the collector as commercial space to fund the operation of the drone. The first prototype we built is 50 meters by 50 meters.
Wow, okay.
So we have 4 rooms on our collector, and we have a fully functional lab. We want to keep the operation expense as low as possible, and AI is an enabler. Just imagine if all the drone is controlled by AI, then we don't really have human operation costs, so it can just go clean up forever. Yeah, so I think AI is just part of the whole kind of system.
Where are you at right now? You said you're piloting it? Okay, so interesting. So, and I'm looking forward to seeing that in action.
Yeah, we really want to deploy this on the river because majority of ocean plastic come from river.
I see. So do it at source.
Yeah. So just imagine before river goes to ocean, we have a station, drone that clean up the river, and that station, if it's big enough, we can operate this as a restaurant, as a museum, as a hotels, and that revenue generated will fund the drone. And this is how we scale up the ocean cleanup. And then ultimately, I want to use the plastic I collected to make phone cases or other products. Yeah.
Is it a whole new ocean line?
Yeah, but I think that's how kind of we progress as a human being, and then that's kind of the bigger problem we want to solve. Yeah.
Thank you so much, Eric Wang. What a pleasure to speak to you.
Thank you so much.